daarmee kwamen we dus in gesprek met Jaap. En daaruit is het idee gekomen om hier in Artone deze presentatie te doen. Waarom Artone? Hier wordt de muziek gemaakt, die wordt hier gespeeld, die wordt hier opgenomen en vaak daarna uitgegeven op vinyl, het wordt hier ook geperst. En hier hebben we dus te maken met de opnametechnici, die vaak een eigen input geven inmiddels hun mix. Gevolgd door de muzikanten die daar met hun eigen stem zitten van ja, maar ik zou het zo willen hebben, ik zou het zo willen hebben, ik wil een kleine verandering. En die hele activiteit rondom het produceren van muziek, gedaan door mensen die we met z'n allen op onze playlist hebben staan, zeg maar. Dat leek ons een mooi uitgangspunt en een mooi startpunt ook om hier in Artone een aantal van die mensen aan jullie voor te stellen.
Belangrijk, het is heel fijn als je een zanger krijgt die kan zingen, want dat scheelt ons al heel veel reparatiewerkzaamheden, als ik het zo mag noemen, wat tegenwoordig allemaal kan. Ik hou van live. Wat wij hier heel veel doen is de direct-to-disc producties. Dat betekent dat wij een band hebben, die komt in zijn totale, met backgroundzangeres en alles helemaal in zijn totaliteit komt die hier staan. En die gaat het nummer dus in één keer brengen. Er wordt niet gedubt, er wordt ook niet naderhand even Pro Tools even van ons staan. Nee, we gaan hier staan, we zorgen dat het nummer goed is. Wij, Martijn en ik, zorgen dat de klank is zoals ze willen hebben. En dan gaat hij direct naar de snijtafel. Dus we moeten de microfoons allemaal inregelen. Dan wordt de mix gemaakt, dan wordt de mastering gemaakt voor het vinyl en dan wordt de snijtafel gestart. En dan gaat hij direct in de groove. Dat is als we het over muzikanten en artiesten hebben, een discipline. Want er zijn wel eens bands geweest die zeggen van god, ik doe 4 nummers op mijn kant. En als nummer 4 dan fout gaat, oh, kunnen we dan even nummer 4 overgaan? Nee, een plaat begint aan de buitenkant en die loopt in één keer door naar de binnenkant. Dus je zal het hele programma, wat live is, zou je in één keer moeten doen. Dus als nummer 4 fout gaat, ga je weer met nummer 1 beginnen. Dat betekent dat je wel, als je hier komt en als je hier dus een direct-to-disc recording gaat maken, dat je wel weet wat je gaat spelen en niet gaat zoeken van zal ik dit. Nee, klaar, je moet het weten en dan zorg dat het zo goed mogelijk erop gaat. Dat is een specialiteit van ons en dat kunnen we dus aanbieden. We hebben ook een drukkerij in de buurt, dus iemand kan met zijn artwork onder zijn hand en zijn gitaar komen. Die geeft het artwork af. We nemen de disc op, het gaat naar de perserij. We hebben zelfs een wereldrecord, zal niemand ontgaan zijn. Dat we nummer 1 zijn in de wereld, Jack White vindt het jammer, maar wij zijn nummer 1. Nu in 2 uur en 49 minuten hebben we het voor elkaar gekregen op het moment dat we, Martijn en ik, de opname starten. Dat de band begon te spelen, is de klok gestart en toen de eerste plaat verkocht werd, toen is de klok gestopt. 2 minuten 59, daar zijn we trots op, Martijn. Zo is dat.
expertise speelt in deze een ontzettend belangrijke rol. En daarom is het ook zo vreselijk belangrijk wat er hier in deze studio gebeurt. Meestal, als ik mezelf terughoor, zeker als het om live opnames gaat, dan help. Maar vanuit het concertgebouw was dat echt goed. Je moet je voorstellen, die live opnames, wordt op de zondagochtend uitgezonden. Heet Spiegelzaal. Dezelfde naam als de locatie waar die concerten zijn. En de studio die zit daarboven en de communicatie die verliep dan, want de engineer was eigenwijs, die wilde per se de microfoon op een bepaalde plek hebben. Ik dacht, oké, ik heb een wat andere mening, maar goed, de communicatie verliep uitstekend. En ik hoorde het terug en voor het eerst was ik ook echt, dat ik dacht van, yes. En wat blijkt nou? Diezelfde opnametechnicus is door Elko opgeleid. Dus de appel valt niet ver van de boom, wou ik even zeggen. Voor wie niet bekend is met het fenomeen, dit is een 12-snarige gitaar. Als ik over dit instrument begin, dan zitten we hier morgenochtend nog, dus dat gaan we niet doen. Even één klein detail. Kijk, dit is een Braziliaans palisander van de allermooiste soort. Ik zal meteen blijven vertellen, dit is een strikt verboden houtsoort. Dus het Braziliaans palisander uit het regenwoud. Is sinds 1992 volstrekt verboden. Dit is legaal. Maar ik krijg er ook een certificaat bij. Nee, is geen eigen. Nee, dat exportverbod is echt heel strikt. Er mag gewoon niks uit. Onder Bolsonaro ging dat een beetje anders. Maar er gingen wel meer dingen een beetje anders onder Bolsonaro. Maar goed, dat is een ander verhaal. Nee, ik krijg een certificaat bij dat dit hout is van voor 1992. Dit dateert ergens vanuit de jaren 50. Het is zelfs zo erg, op Schiphol zijn de mensen getraind in het herkennen van Rio-palisander. En als je niet kunt aantonen dat het legaal is, wordt het instrument geconfiskeerd, je krijgt het nooit meer terug. Dat was even. Menno heeft onder andere bedacht om er een derde klankgat in te maken. Dit is volstrekt uniek. De eerste gitaar waarop het is toegepast. Dus ik heb als het ware een monitorsysteem met het derde klankgat dat naar mij toe gaat. Goed. Voor wie niet weet wat een 12-snarige gitaar is. Nou, het volgende nummer heeft iedere audiofiel was ongeveer in de kast staan. Dat is. Nee. Nee, nog erger. Dat het fenomeen 12-snarige. Alleen deze is een toon lager. Maar goed.
Why can't we just reproduce reality? Why can't we just put microphones in front of this guitar and we will have the exact same experience? And Guido said, yeah, but the acoustic properties of the guitar are so different that you cannot make a loudspeaker that behaves like that. And maybe if you could, it would not be able to reproduce a trumpet. So it might be a good guitar loudspeaker, but not unusable for anything else. And then John comes up and says, "Yeah, I got another guitar. It has different acoustic properties." And then I have to start all over again with my loudspeaker. So it's impossible. And then apart from that, the source, an acoustic source like you just heard, it radiates in all directions from this position, different frequencies in different directions. And then if you see what we have two loudspeakers. And the two loudspeakers, they have their own radiation patterns. And the interference of the two gives you the illusion of a guitar being projected in between the two loudspeakers. So it's not the same. But following my story, I would say it's not so bad that it's not the same, because we know deep inside that it can't be the same, because we know we are mortal. But the fact that we are confronted with a glimpse of immortality, and the fact that we feel that it's different, but it feels the same at the same time, that makes it so intriguing. So I think that the combination of non-perfectness on the one hand and striving for perfectness on the other side, so making an illusion that everybody will know is not real, but at the same time trying to work on the details, making it as real as possible, that combination is very touching and emotional, involving. It must be something like that that keeps us going to work every day, because it's not just the engineering, it's of the sound engineer who is making the recordings, but it's also the engineering of the audio engineers who develop the equipment, because the details that betray the fact that it's an illusion, they pop up everywhere. And that brings me to the MU2. Because the MU2, as you probably have already thought of, is a sister product of the MU1 that has been introduced, is it 3.5 years now? Maybe, yeah, I think 3.5 years back. And the MU1 has become very well known as a digital music source that works really good with third-party DA converters, and in our case with the LS1 loudspeakers that have digital inputs. The origin of that design was indeed that it should work with the LS1, which has digital input. So we stay in the digital domain and we only go into the analog domain inside the loudspeaker where the DAs are per driver installed. Now, since many people also use it with a third-party DAC, we knew that again by integrating functions we could set another step. And maybe if you look at the LS1 MU1 system and have listened to our stories before, you know that by integrating we buy freedom. Because ultimately we want freedom to make the design what we liked to make. So by integrating we buy the freedom. And why do we need the freedom? Because all audio is ultimately a compromise. And if you have full freedom, you can choose your own compromise. And that's what we're after. We want to be able to make our own choices in selecting the right compromise according to us. Now, we did that with the MU1 if you combined it with the LS1. Now, if you combine the MU1 that has digital outputs only, but you don't use it with the LS1, you combine it with any third-party DAC. For those customers who don't have LS1s, who would like to use an analog passive speaker, or maybe an analog active speaker, or passive speaker with power amps, that's a huge market, so it's a commercial, interesting market for us, but it's also it opens different doors than the full integration that we strive for with the LS1 system. And again, by integrating all the functions, we buy freedom to put the compromise in the right place. So to sketch now what we integrated in the MU2, it's still just like the MU1. There's a Roon core inside, so it's still a digital music source, and through Roon you will be able to play local sound files. There's a built-in SSD drive to play NAS files, to play external USB drive files, everything that you know from the MU1. Of course, you can through Roon also hook up to Tidal and Qobuz on internet streams. So that part is the same as the sister product. There's also still digital inputs on the back. So if you have a CD drive and you love to have the physical disc and to just cherish a couple of albums, and you may have ripped them, but once in a while you just want to feel the physical object and you want to play it, or somebody brings a CD, whatever. You like to play your CDs. But you can connect the CD transport on the back. There's also an input for your smart TV, so you can enjoy your movies or your television or whatever you watch in the living room. You can also watch that through the MU1 and now also with the MU2. So the sound quality of your television will also benefit from that real high quality processing that's inside that I'll come to in a minute. And that's already partly also known from the MU1. And then instead of with the MU1 going into ASEB or SPDIF digital outputs, including the clock, which was the core asset of the MU1, we now enter our own home-built digital to analog converter. It's a discrete design. That's not new. I'll come to the design in a minute, but we do it in our own way, and that's because by having the full integration, we buy the freedom to put the compromises in the place that we want to have it. After that DA converter, there's another integration, an element that we integrate, and that's the line amp. Because if you would not have a line amp integrated, and we would have a volume control integrated, and somebody has a phono stage that he has connected to his record player, he would need a second line amp to hook up his MU2 to, and then go through a second line amp, and then be able to switch between the phono stage and the MU2. So we figured that by integrating the line amp and also an analog volume control, which is relay based, we have very high quality line amp possibility as well, and again a full integration of functions. There's two sets of analog inputs on the back. There's XLRs and RCAs, so you can connect whatever you have, a tape recorder maybe, and for sure, of course, phono stages can be connected to the back of the MU2. And then the only thing really that you still need is a pair of power amps or a headphone, because you can connect with a 6.3 millimeter jack your whatever headphone. Actually, some people said, yeah, but now we have headphones with XLRs. Do you have a solution for that? Well, the line output of the MU1 is powerful enough to also drive headphones from the XLR output. But in general, we would recommend to use the jack output for headphones. Very briefly, what we did is we looked at digital to analog converter design, and we saw that the majority of designs have certain advantages and certain disadvantages. And they all have, again, a certain compromise. We looked at all the compromises that were taken in the past. Now, very well known is multi-bit DAC. That's where we all started with. You still have them around, and then they're called NOS DACs, non-oversampling DACs. What's meant with NOS is there's no digital processing going on. Your bits, whatever the source is, go directly into the DA converter, the multi-bit DA converter, no digital processing whatsoever. And then you go out of it. Now, that was not standard with multi-bit DACs. Actually, the first Philips CD player was multi-bit, but already had digital processing. What is it used for? It's used to get rid of the high frequency noise above 22 kilohertz in a CD case. And you can do that with an analog filter, you can do that with a digital filter. The filter has to be so steep that an analog filter will have a lot of phase shifts, so you'd rather not do that. And you can make a phase linear filter in the digital domain. So from the start onwards, with digital audio in hi-fi, through the Philips route at least, and very quickly also after that Sony followed, we are used to digital filtering as the de facto standard. And that was used in combination with the multi-bit DACs, multi-bit format DACs. Now the next step that was taken was that people realized that if you have a multi-bit DAC, that all the bits have to have a certain precision. And actually the most significant bit that gives the biggest step has to be equally precise as the smallest bit that you have. And that's a crazy amount of precision that you need. You had to laser trim the chips after they were produced. Very expensive technology, and you could maybe reach 18-bit precision, but, well, if everything was right. So very soon, to make it more affordable, there was a new technology introduced. Ultimately, that led to Philips bitstream DACs that had just 1 bit. Now, how can you have 1 bit instead of 16, which were on the disk? You use a technology called oversampling, which means you run 64 as many bits as are actually on, or samples, I should say, as are actually on the disk. And then you use your digital filter to interpolate, to calculate the in-between lying bits. And because you have such a high sample rate then, you can throw away a couple of bits. That means the noise goes up, but because the sample rate is now so high, you can push down the noise in the audio band and let the noise grow above the audio band. And that's why it's called noise shaping. The total noise stays the same, but by noise shaping, you push down the noise in the audio band and the noise goes up above it. And by going on and on and on further, you can end up with just 1 bit that has a lot of noise, and eventually you just push it down further and further to achieve the needed resolution or noise level in the audio band. Now the 1-bit solution also had a problem, and the problem is that you now have 2 calculations that you need to do. One is the noise shaping and the other is the digital filtering. And soon they realized that the noise shaping was a little bit problematic to do that right with 1 bit. Unfortunately, they found out after the Super Audio CD was already created, but even before it was released. And so the chip manufacturers moved onwards to the next style, but the Super Audio CD was limited to that single bit. And single bit DACs can sound real good, but they are not the ultimate answer. So what you see then is that the manufacturers have introduced DACs with slightly more bits. So 2 bits, 3 bits, 5 bits. And that seems to be the current state of affairs. And that's true for DACs in chips, and it's also true for discrete DACs. And then what we figured is where it still goes wrong is in all that digital processing. We have the digital filtering and we have the noise shaping. With the digital filtering, we already learned with the MU1 that by applying way more processing power to that and smarter algorithms, you can improve the sound quality of the connected DAC. So that was at least one side of things that we could incorporate in our discrete DAC by using the MU1 technology of high quality digital filtering. Why did we do digital filtering? Because we added the extra bits and we needed to do the interpolation. So they actually create a lot of the new audio. And the new audio needs, of course, to resemble the original audio as good as possible. And we learned that you need way more resolution to do that right. Now the second thing is that noise shaping and the amount of bits, and you can have more bits, but then the calculation of the noise shaper becomes more complex. And so what we did in the MU2 is we were looking for the simplest form of noise shaping that we could make linear without the 1-bit problems, but not more. Because if we would have the simplest version, and then dedicate a lot of processing power to that, the net effect would be that the simple processing gets very high performance. And in our opinion, you can better have something simple at a very high performance level than something slightly more complex, because with the same processing amount, you then lose precision. And that's where we ended up with our famous 1.5-bit DAC topology. And people think, 1.5 bit? I don't see how that works. Well, maybe you learned a little bit about binary coding. So with 1 bit you have 2 options, and with 2 bits you have 4 options. Now, yeah, with 1.5 bit you have 3 options. So it's in between 1 and 2 bits. How can you imagine? Let's say if you have like voltage levels, you have 0 volt plus 1.5 volt and minus 1.5 volt. That's 3 levels. And then you can say, okay, I make a 3-level DAC. And we can call that 1.5 bit. And you need to do some crazy math to make that work, but it's possible. Now we don't do it in the voltage domain, we do it in the time domain. So that means that we have just 2 voltage levels, but we can vary the length of the pulse width, so to say. So we have a PWM, pulse width modulation, also well known from the switch mode amplifiers, etc. And you can do the pulse width modulation with as many bits as you like. There are competitors that use 5 bits to define the width, the various width of the pulses. We do just 1.5 bit width. Why? Because that makes it simpler. And if it's simpler, you need less processing power to do the same, but we apply a lot of processing power and then you do the simple thing at a real very high quality level.
Dave, I used to explain them that you're here to present us the Fenestria, and then with a little bit music, and then after we go to introduce the little loudspeaker of the PMC line. Yes? So please go ahead.
Thank you everyone. So yeah, I apologise a little bit late today, but I think as Bert's explained, I had a few flight issues this morning, but I'm here. So my name's Dave, I'm from PMC. PMC are the professional monitor company. We're a British company. We're 32 years old. And we were founded by Peter Thomas and Adrian Loader. Peter was head of engineering at the BBC, and Adrian was a supplier to the BBC from Bausch. Both engineers and enthusiasts, and they created the very first PMC loudspeaker. And really, even look at the Fenestria, we can see the sort of heritage in the transmission line, which is now advanced transmission line design. Every PMC loudspeaker that has been before and that is to come will be an advanced transmission line design. And we use that for a number of reasons. It's not unique technology to us, it's a very old technology, but we use it because our business is across both the professional mixing, mastering, recording channel and of course home audio. So 50% of our business is still in the recording, mixing and mastering business, and the rest, as I say, is expanding into home audio more and more. But the same design principles really work in both camps. A lot of engineers like to have a very full bandwidth and a very rich, deep bass, but not necessarily at very high volume. And transmission line enables us to do that. So we can have a very modest listening level, but enjoy very rich, deep, low frequencies, very low distortion, and they work very well within the room. So the Fenestria that we have here is our, if you like, really the pinnacle of our passive loudspeaker design. Our engineers were tasked back in 2015 with a 3-year project to really sort of showcase what we can do within the passive loudspeaker domain. And the Fenestria was the result. And as a sales guy, I knew nothing of this. So literally Munich 2018, we rocked up 2 days before and we were presented with this. So it was a secret project within PMC. And the engineering team were really charged with going out to find new technologies and trying to embrace lots of different influences from outside of the traditional domain. So what they did was they really looked at a number of 2 things really. I guess isolation was a key factor in developing this product, and equally cancellation. And they really wanted to produce a loudspeaker that you couldn't hear. That was the challenge, to try and generate everything except the loudspeaker cabinet itself. And we do that a number of different ways. So in terms of isolation, right down from the base, the crossover is isolated and mounted inside here. The nest, as we call it here, is isolated from the twin bass cabinets to prevent any unwanted resonance or influence, to enable the mid and the HF to work effectively. The HF is rubber mounted, silicon mounted, as is the mid-range. Now the mid-range is our own, so we produce this all in-house. The tweeter is a SAES unit, and as I say, we try to encompass lots of different technologies. The greatest of which I think which dictate the design really is the cancellation. So the wings on the side actually move, they're rubber mounted, silicon mounted. And the idea behind that was in measurements we could show that even at modest volumes, of course, there's a resonance within the cabinet, and taking influence actually from buildings, in fact, the way they kind of mass damp within an earthquake environment. The same applies. So as the resonance is generated from the cabinet, the base unit, the wings actually work against the cabinet. So these actually float and cancel out all but everything of the original resonance within the cabinet. And we do that, as I say, to reduce everything but the music itself. Laminaire that you see at the top here, this is a technology, there's an awful lot of air moving in and out. So the transmission line design is effectively a pipe. And there's a lot of air coming in and out, and turbulence is the real killer here. So again, it's trying to reduce everything but the music. We need to reduce turbulence in the line, and we do that with the laminaire, which actually speeds up the airflow at the exit point, reducing chuffing and giving you a nice clean bass. And the transmission line design is such that everything but the very lowest frequencies are removed. So within the line there is obviously different pitches, different lengths, and absorbent material, and that then reduces all of the unwanted resonance and rear radiation from the drivers, which means that the frequencies exiting from the port are pure and clean and the lowest frequency. So this was 3 years in development. The Fenestria, it kind of demonstrates what you can do with a passive loudspeaker. And in testing, a lot of people assume it's an activated speaker, because of course our heritage, our very first loudspeaker was an active model. But certainly partnering with the amplifier and the electronics here, it's the best, not just because I'm here, but it's the best I've heard this present. I think the Fenestrias are playing beautifully today, so it's a remarkable thing. We're quite unique really at PMC. We're a privately owned company, which within the sort of loudspeaker market is very unusual now. So Peter Thomas, our co-founder, he's still in the business, he's our chairman. His sons and daughters, we're a family business, are in the company. So Oliver Thomas is head of engineering, his son. Tom Loader, his stepson, is head of our production, he's operations director. The daughters are in the business. So we're quite unique really. It's a very small team, a relatively small company, but our footprint is large. We can be found in some of the largest mixing, mastering studios globally. We work with quite a few TV production companies, film production companies. We have a business and an office over in Orange County in California, and that's there to service the film industry. So many of the blockbuster movies that you'll see will be mixed and mastered using PMC. And they typically sound a lot better than I do, so I think we'll probably play some music. Yeah, cool, okay. Thank you.
Yeah.
So Prodigy is it's kind of from studio to home. What we're trying to do to produce a really good loudspeaker. Obviously, you have quite a few conditions to go through, quite a few parameters you have to stay within. Our design engineers many years ago decided that there was no rule for hi-fi loudspeakers versus our Pro heritage. It's the same loudspeaker. It's there to do the same job, which is to replicate and reproduce music in sort of the most fundamental and cleanest way, low distortion, dynamic, open, natural reproduction. So we kind of came away from this idea, our philosophy of trying to produce a loudspeaker for the home and then one for the studio, because it's the same thing. If you get everything right, it's the same loudspeaker, the same controls are in place. So Prodigy is testament to that. So, for example, the HF unit that we have here is actually from our Result 6 Active Pro monitor. The LF that you see in the new Prodigy design is from our CI series. Transmission line, of course, manufactured in the UK. So the same design philosophy, again, advanced transmission line, handmade in Britain, same signature sound that you have with the Fenestria. So we're going to play some music. It's weight and scale. So as you, of course, as you go up the hierarchy of PMC, you get more weight, more scale. But the detail, the imaging, and say that the reproduction music is the same. So hopefully we can demonstrate that. But these are, so they're brand new. The Prodigy, there's a 5. This is the Prodigy 1. There's Prodigy 5, which is again a 2-way, but a floor stand. And they'll be shipping now. They're on the way to you now. So they'll be landing in the next couple of days. But yeah, I hope you enjoy listening to them.
Okay, there we go. Hartelijk dank voor jullie komst.